Chem R is large language model for chemistry. So large language models have very adaptable base transformers. Transformers will learn whatever you teach them. So we need to use specialized data and ways of teaching to create a better chemistry large language models than just using the global internet data. So the goal for this model is to teach it to reason like a chemist. And existing LLMs fail at chemistry because they lack the fundamental chemical knowledge. So we need to have separate curated data just for this. They're not trained to produce well-structured, properly, correctly structured outputs and chemistry reasoning. So as a result, they perform poorly and unevenly across different chemistry tasks. So in this paper, researchers built a 3-stage training pipeline that teaches the model to be a lot better at chemistry. So they created a lot better 8 billion parameter chemistry model. The first part is starting from some strong base large language model like Llama 3.18b and just teaching it a massive amount of general chemistry knowledge like conversions from different types of notations, equations, matching molecular structures and their textual descriptions, basic reaction mappings like what reaction gives what products. So this is the general knowledge in the beginning. And it's a lot about memorizing the fundamentals. In the second stage, they want to create answers to questions such that those answers also provide correct reasoning paths. So if a question is given, there is a reasoning path on how to reason about the question and the correct answer. And the way they generate those is they first start by giving those questions to bigger model, and they tell it to reason about it and to give the answer. Now they generate a bunch of these answers and see which reasoning paths led to good answers, correct answers, which reasoning paths didn't. So then they use that to create a rule set, a book of reasoning paths or types of reasoning. For example, step 1, analyze reactant structures. Step 2, identify all key functional groups and their reactivity. So they will pick reasoning paths that are most likely or most often lead to correct answers. And they also look at reasoning paths that resulted in a wrong answer and they add those hints. So don't do this, don't reason like that. So the result of this is like a recipe on how to reason for specific groups of problems that also include these things like don't do this, don't do that. And it's all written in text. It's like a text with rules. So in the next stage, they will use these rules to generate perfect training data, or I guess as perfect as it gets. So in the next stage, they will give the question, this rule book explaining how to reason, and the correct final answer. So this big LLM will now generate as good as it gets reasoning paths to go from question to the final answer. Remember that previously we just looked at a lot of possible reasoning paths, so we chose ones that consistently give correct answer or the best ones, and then we give those reasoning paths, explain to this big LLM again how to reason and give it correct answer so it reasons correctly. So that's our training data. We generate our training data like that for the smaller model. So in the phase 2, they will train the model on these reasoning paths. And in phase 3, they use reinforcement learning to improve the reasoning and model's understanding of how to solve these problems. It's the classic reinforcement learning LLM reasoning. So you give it a question, it generates a few answers, it rewards correct answers and punishes wrong answers. You can just search on my channel PPO LLM reasoning and you will learn a lot more about how that works. But they don't train on any type of problem with equal likeliness. They actually find which problems are more difficult for the LLM and then train on those more. Like they can just classify where the accuracy is like very low versus very high. And then in the study plan, the low accuracy problems will get a higher chance of being selected and trained on. So in phase 1 is the supervised fine-tuning on question-answer pairs to memorize more knowledge about chemistry. Phase 2 is distilling perfect reasoning from the teacher to teach it how to reason. And now that it knows the format of reasoning, phase 3 will use reinforcement learning to improve that reasoning, especially the weaker tasks, the weaker knowledge it has, and reasoning. Notable difference in this method is this phase 2, where the researchers are focusing a lot on the process of reasoning, teaching it how to reason, and then just reinforcing that reasoning later with outcome rewards. Now, usually LLMs are trained just with outcome rewards, so researchers don't focus on the process of the reasoning, just the outcome of the reasoning, if the answer is correct or not. But this paper focuses more also on the process of how to reason. Now, is this better or worse? It should be better if you have less compute. If you have more compute, a lot of compute, then it's better to focus just on outcome and use sheer amount of compute to let the model try many different, and it's gonna find better than you can teach it. That's gonna be it for this video. Join my school to become AI researcher, and see you in the next video.